So in this question, buffer solutions containing sodium carbonate and sodium bicarbonate range in pH from 10 to 11. The chemical equation represents the equilibrium between the carbonate and the water, and the table lists the composition of 4 different buffer solutions made from a combination of both of them. Which of the following chemical equations describes what happens in the buffer solutions to minimize the pH change when small amount of strong base is added? So what is my buffer made from? A carbonate and a bicarbonate. And which one is weak acid and its conjugate base? I can see that the water has given proton to the carbonate. So this means that the water is my, who is here? Is my acid. So this is my acid, and this is my base. So this means that acid is H2O, and carbonate carbonate is actually my base. So if this is a weak base, where is its conjugate acid? The conjugate acid is the one that's produced when this one gains a proton, which is HCO₃ minus. So this is made from a weak base and its conjugate acid. This is how the buffer is formed. We can also say the opposite, that the HCO₃ is the one that has given a proton to the hydroxide. So the proton came from here to here. So this means the HCO₃ is my weak acid. So I can say that HCO₃ is my weak acid. And the product of the loss of the proton in it is CO₃² minus. So it is the conjugate base of it. So I can say also it's made like that in the opposite direction. I said you are adding a small amount of strong base, and when the strong base is added to the buffer, who is responsible of defending the buffer? So the defending the solution from changing the pH, the OH minus is attacking the solution. It will be defended by the weak acid part. So it will be defended by the weak acid part, which is the HCO₃, the HCO₃. And what will be my product? You know that this is an acid-base reaction. So the same way the carbonates reacts with the base to form salt and water, the bicarbonates will do the same. It will form also the salt and the water. So H2O and CO2 and the oxide. So this formed for carbonate. So it is CO₃² minus. So this is what happens when you add the base, the strong base, to the bicarbonate. The H2O and CO₃ are formed. Now the question is, which of the following chemical equilibrium equations which shows what happens in the buffer solution to minimize the air? So this is the equation we are looking for, the OH minus with the HCO₃ and forms carbonate and H2O. So this is my answer. My answer is number B. Okay, let's summarize this. If you still feel lost, if you want to know, how we answer this one, we try to know what is our buffer made from. So you check the equation, the original equation. Take care. The difference between this equation is the equation of the formation of the buffer solution. Because here acted a carbonate with water, it formed bicarbonate and OH minus. This is the equation of the formation of buffer. They added an excess from here, an excess from here. So this excess is his weak acid. This excess is his, this excess is his base. This excess is his base. And the water gave a proton to it because it becomes OH minus. So this is the excess from the base. And this is the acid. And he formed the conjugate acid here. So conjugate acid is a base and a conjugate acid. This is what formed the buffer. The buffer has two parts to protect the solution. It has a basic part and acidic part. When you attack by OH minus, the acidic part defends. That's why we use the acidic part here. And if you added excess from the H plus to the buffer, the basic part is the one that defends it.